It is another example for the Mann-Whitney test. Yep, here is the brand A, B, two groups again. And now we can rank them. But before the ranking, here is the step number 1, the hypothesis. And we just compare if they are not equal to. So it will be two-tailed. Okay, so now the rank. Let me see, which one is the smallest one? I think the 2112, that is the smallest one, but we have two 2112. So one of them is the rank number 1 and the other one is the rank number 2. So when we have a tie, then we take the average of the rank number 1 and 2. So the rank will be 1.5 and 1.5. And the next rank is must be third, the 3, as a 2144. That will be the rank 3 because already we assigned the rank 1 and 2. The next one is a 3, and the next one will be 4, 2160. And the rank 5 will be 2176. And the rank 6 is a 2208. And rank 7 is a 2240. And the next one, the rank 8 will be 2281, but I'm sorry, the 2282, 88, but we have another 2288. That is another tie, but they must be the rank 8 and 9, so the average will be 8.5. So already we assigned the rank 8 and 9, then the next one is rank 10. Rank 10 will be 2304, but it is the another tie, it's another 2, 2304, and they must be the rank 10 and 11, so the average will be 10.5 and 10.5. So we assigned the rank 10 and 11, and the rank 12 is a 2368, and rank 13 is a 2384 and 2384. They must be rank 13, 14. The average will be 13.5 and 13.5. And the next rank will be 15, 16, 17, 18, 19, and the biggest one is a 20. So we have n1 equal 10, is n2 is equal to 10. So it's a totally we have 20 observations. Then now the second step, we need the rank sum. The m was the test statistic. The rank sum from the sample number 1, that will be 83. If I want to get the other rank sum, then I can expect the maximum sum of the rank as must be 20 times 21 over 2. So that is 210. It's a 210. So the other rank sum must be 210 minus 83. That is a 127. So you can check. You can check by yourself. It's a sum up is a 83. And the other sum up is a 127. But we are going to take the rank sum from the sample number 1 will be the test statistic. Then now we have to take the critical value. So for the critical value, let me say is alpha is equal to 0.05. Then the possible value for the test statistic m from 0 to the maximum is a 210. And now we have a 0.025, but it was the two-tailed, so we have to split half and half. Left tail, there is a 0.025, and the right tail is the other is a 0.025 because it is a two-tailed. So with the sample size is a 10 and 10, and the probability 0.05. So let me go to the table. Yep, it's a table here. 10 and 10 here. And the upper tail probability. Even though the table suggests here is alpha, but that is the probability. It's actually that is the right tail probability. So now we need the alpha over 2. Okay, so I have to go to the 0.025, and the critical value will be 131. So let me go back to here. The right limit, that is the 131. But we have the smaller one, smaller rank sum. So it's actually we need the left one. So it must be 210 is minus 131. So that will be 79. So here is the left end is less than 79, and that is the right end is bigger than 131. But the test statistic is 83. Yep, here is the statistic is M. It's 83. It's not in the left tail or the right tail either. So the decision will be fail to reject the null hypothesis. It's a fail to reject the null. I'm sorry, it's not this one. It is fail to reject the null hypothesis. Then the conclusion should be they are same. They have the same mean. Okay, so in this example, we have many ties. So be careful to assign the ranks. And it was a two-tailed. So we have to split. We have to split is half and half. So we have to look for the upper tail probability 0.025. It's not 0.05. And the two sample size and 10 and 10. So we take the right tail critical value, but it's actually we need the left one as well. And the test statistic is not in the tails, so we do not reject the null hypothesis.